Yes, ma'am.
Yes, ma'am.
Uh-oh. Let me know when you can see my screen. Oh, wait, wrong thing. Shoot. We good? Is the due date for chapter the 19th or the 26th? Which chapter? The chapter we're on? What chapter? Let's see. I don't know. Whenever we finish it. So today's Tuesday, right? This is Tuesday. Wednesday. Oh no, it'll be the 26th. It'll be the 26th. I don't think I could push it and get finished this week with this chapter, but I don't want to push it. We'll probably finish on Monday of next week. And then we'll start the last chapter. So the 26th, is that day? Yeah, the 26th. Mm-hmm. It's a short chapter. I mean, it's not, I could push it, but I don't want to rush y'all. I want to make sure y'all are spending time getting through the homework. So we'll make that one the 26th. And this week you're supposed to be testing, right? When's the test due? Mm-hmm. Yeah. So the test, worry about the test this week and work, of course, on this. Get the test done and then stop it. Cool. Okay, where are we? We did this. We're on the application problems, right?
Yes, ma'am. We should be on example 9 on 102.
Oh, okay. Example 9 on 102. Okay. Here we go. So on example 9, you should see like there's this, oh my gosh. There's like this board, it looks like. It looks like this board. And then you have these strings. Okay. And off this string, you have a weight. Don't look at my picture. Look at your picture. 100. And then they tell you that this is 50. Right? And this is 30. Is that cool? And so I'm going to make this point, and this is what we were talking about before, is like if you have the opportunity to make your vector in component form, meaning it's starting at 0, 0, then that's what I would do. So here's my coordinate plane. I'm making that value here at 0, 0. Okay. And it says 100-pound weight hangs from a string as shown in the figure. Find the tensions T1 and T2 in the string. So it's asking you to find these specific vectors. It wants these vectors. And it's calling this one T1 and this one T2. Do you agree with that? So if it wants you to find these specific vectors, remember, what are the two things that vectors have? Anybody?
A angle and a distance.
Yeah. Length, a magnitude, and an
That's
angle.
right.
No, that was perfect. Okay, So I can kind of already see what these angles are going to be because we know geometry. What is this angle here? Because remember, when you're looking at angles, you always start from the positive x-axis. So what is this angle? Anybody remember alternate interior angles from geometry? Yes, thank you, Jude. It is 30. If this is 30, remember the Z thing? Like whenever you see a Z, so here's a Z, angle of elevation is equal to the angle of depression. So if that's 30 degrees, then this is also 30 degrees. So I think that T2's angle, and I'm just going to make some little notes here, angle is 30 degrees. Okay. And so let me get a different color. What about T1? What is the angle from here to there? Close?
130.
130 degrees. Are we okay with these angles? Let's make sure we're okay with the angles before we start trying to find the magnitudes. We okay? Moving on.
Yes, ma'am.
Okay. So the next thing that we're going to talk about is I have no idea, but I have angles, and I'm going back to what we've learned so far. And we know that, for example, for T1, here's T1, that it's going to have a horizontal and vertical component, right? So I'm going to have the magnitude of T1, and I'm going to call that A, because I don't know what it is. So A cosine of 130, that's going to be the I component, plus, hold on, it could be the hospital. Hello? Hello? Who's this? I'm sorry? No, that's the wrong number. All right, it's okay. Bye-bye. It's okay. Bye. Okay. A sine of 130J. So that's T1. And then for T2, we're going to have another, it's obviously not the same length. So I'm going to call that B cosine of 30 for the I component plus B cosine, sine. Sorry, sine. Well, yeah, we don't know the magnitudes. T1 absolute value V thing. I'm basing, yes. So I'm basing this off of page 101. If you go to the top of page 101, it says that vectors, I'll give you a second to get there. If you're looking at the top of page 101, it says that vectors have a horizontal and vertical component. We talked about this yesterday. And that you can express your vector as your magnitude V cosine theta of I plus your magnitude V sine theta of, that should be a J. That's a typo. That should be a J. Yeah, it's supposed to be a J. I didn't even notice that. Okay, so that's supposed to be a J. So then I'm expressing it this way for both vectors. Is that cool? And this right here should be 130. That should be a 1. Ooh, that's a 1 in there. Let me erase that. I'll make it better. Okay. So we don't know what the magnitudes are. We know what the angles are. We found those. We're okay with that. But we don't know what the magnitudes are. So that's what we're trying to figure out. Does this make sense? So far so good on these? On my setup?
Yes.
Okay. So you have this string. Do you agree with that? It's the same string. I'm just splitting it in a different way with this weight. Am I shifting this I'm starting to think of like, okay, how am I supposed to find this? Am I shifting this string at all sideways? Like, what is the horizontal component for these? How is it being pulled? Is it being pulled sideways?
No, it's being pulled
No.
down.
Okay. So then I came over here and thinking, okay, well, let me think about my horizontal components. So from here, I'm going here. Let me think about my horizontal components. That means that A cosine of 130 degrees plus B cosine of 30 degrees is going to have to equal 0. Right? Because you said I wasn't pulling either parts of the string left or right. So that means that both of the horizontal components together has to equal 0. And then if I think about the vertical components, that means that A sine of 130 plus B sine of 30 has to equal what? What did you just say about the vertical component? Well, I'm gonna go ahead. I agree. It's gonna be something. I think I'm just gonna put 100. It's just gonna have to equal 100. I understand what you mean by like negative 100 because it's pulling it down, but we're just talking about the tension itself. It's 100-pound weight. Does that make sense? I don't. What's negative? What? Where are you putting the negative? No, it's. I'm just gonna put plus. I'm just saying that the tension together has to equal 100 in order to be at equilibrium. The vertical tension has to equal the tension put on the string. So this is the vertical tension together has to equal 100. I'm not looking at direction right now. I'm just making sure that the tensions are equal to each other. Okay. So what did I just set up? What is this? I'm trying to. Maybe. I don't even know. Maybe. I don't know. I didn't even look at that. Um, Thank you, Jude. Yes, this is a system of equations. This is a system. And from college algebra, how did you solve systems? This is before me. In your college algebra class, how did you solve systems? Anybody remember? Substitution method, elimination method, matrices. Do any of these words sound familiar?
A little bit. Not really.
Oh my gosh. Okay, well, you're gonna have to go
Help
back
me
and
out.
I can't. I can't. That's a whole 2-hour lesson. I spent a whole chapter teaching systems of equations in college algebra. So there's no way. So I would go back and pull your college algebra notes or something like that and do it. I'm going to do it using matrices in my calculator. So I don't know what kind of calculator you have, but you might need to Google how to solve matrices in your particular calculator. So with me, I'm going to go. I would set up a matrix. That's probably the easiest way to go. And so this would be cosine of 130. Make sure you're in degree mode. Cosine of 30, 0. Sine of 130, sine of 30, 100. And I'm going to put this in my calculator and I'm going to RREF it. Let me see if it comes out good. I have a TI. So second matrix, go to edit. I'm making a 2x3 matrix, 2x3. Cosine of 130. Cosine of 30. 0. Sine of 130. Sine of 30. 100. Second quit. RREF. That matrix. I think Melissa's right because I don't think this is right. Let me go back. Let's try that again. I know for sure it's a matrix. Maybe I didn't put it in right. Does anybody know how to do matrices? No, that's right. Cosine 30. Nope, that's right. Sine 130. Sine 30. How did I get that? Oh, maybe this is right. Hold on. Okay. I think I know what's going on. Okay, never mind. I'm good. Hold on. We're not getting the. I did it, but the answers seem really ugly. So were mine, but I think I know why. Okay, so I am getting. Let me go off with 100 one. The 100 one. I'm getting that A. Let's see if it comes out right. I think that A is 87.9385-ish. 9385. And I think that B is 65.2704. Okay, let's try and see if this is right. So I got this from using RREF. I solved the matrix. So this is algebra. You might need to go back in your algebra notes or Google how to do RREF or solve system of equations using matrices in the calculator that you have. So once you find your A and B, I'm going to put them back here. So someone do 87.9385, because that's what I think A is, and times that by cosine of 130. And that'll be your I component. Plus the 87.9385 and times that by sine of 130. And that'll be your J component. So let's see what T1 ends up being. $87.9385 times that by cosine of 130. Yep, this is right. And that gives me negative 56.5 I. Plus 67.4J. And I'm going to do the same thing with T2, except for T2, I'm going to put B in, 65.2704 for both of them. And I get 56.5 I. plus 32.6J. And here's my answer. Okay. I think, are y'all still writing this down?
Yes, ma'am.
Okay. I'm just going to recap it just a little bit. So hopefully, I mean, if the point that you get confused is because you don't know how to solve systems, that's before me. But I need to make sure you're okay with the pre-cal part. Okay. So here was this string, and with this string is two vectors, right? This is being strained this way, and this is going to be strained this way, right? It's two vectors. Here's the point where the weight was put down, right? And it's pulling it down. So then it wants to know what these vectors are. It wants to know the vectors. Now remember, you can express vectors in two ways, in component form or in the IJ form. So we're going to express them in the IJ form. So when I was looking at this, I was like, well, vectors have two things. They have angles and they have magnitude. So the angle, the first vector is 30 degrees because of alternate interior angles. Someone said this was 100, which is exactly right. It's a triangle. It's 180 degrees. But you're starting from the positive x-axis. So if you start there and go to tension 1, that's 130 degrees. So I think, is everybody okay with how we came up with the angles? This is the shake head method, except I can't see your heads. So just make sure you're okay with how we came up with those angles. Then, if you go, oh, everybody good on that? Thumbs up?
Oh, yeah, I was just saying yes.
Okay, thumbs up on
Okay.
the angle. Okay, cool. So then the next thing that we did is I looked at the page before and it says, hey, you can express your vectors in the magnitude of V cosine of your angle I plus the magnitude of your V sine of your angle J. That's on the page before. So I'm like, okay, well, I have my angles. That's cool. I just don't know what my magnitudes are. That's the part that's tripping me up. So I did tension 1 and I said, okay, if I were to set it up like this, it would be my magnitude. I don't know what it is, so I'm just going to call it A. Cosine of 130, I, plus, here's my magnitude again, sine of 130, J. And I did the same thing for tension 2. Its magnitude, which is a totally different magnitude, so I'm going to call that B, cosine of 30I plus magnitude sine of 30J. Is everybody okay with how I set this up so far? Shake hand method? Any questions where any of these numbers came from? Okay. Okay. So then what I did was like, okay, well, how am I supposed to find A and B? Because that's what I need. I need to know my magnitudes. So then I was thinking, okay, let's look at the picture. What's being done to it? It's being pulled down, right? So in order to be at equilibrium, let me see what it said. Find the tension of the string. Oh, equilibrium of tensions. So in order for them to be at equilibrium, everything pretty much has to equal each other as far as horizontal and vertical components. But you told me it wasn't being pulled sideways, which is true. It's not, right? So I took the horizontal components from both of the tensions, both of the cosine values, and it's going to be set equal to 0 because it's not being pulled sideways. And then it is being pulled down. So I took both of the vertical components from both of the tensions and I set it equal to 100. The tension has to be able to hold the 100-pound weight. So they both have to be equal to each other. And so then you're looking at this and you have these two variables with numbers in front of them. That's a system. It's a system of equations. So you learned how to solve system of equations using elimination method, substitution method, or matrices. You learned all three of those in college algebra. So I used matrices. So remember, with matrices, you just put the coefficients in. You don't put the letters in. So I put the coefficients in, all the numbers. I RREF'd it in my calculator, and I got this for A and B. So then I substituted A and B back into these tensions so that I can come up with the answer. And that's it. And so those right there are the specific vectors holding that string, holding the weight. All right. So then that's the only thing that we're going to talk about when it comes to vectors. So now we're going to go to 8, and 8 is polar coordinates and parametric equations. Section 8.1 is polar coordinates. And so what I want you to know for polar coordinates is we're learning basically a new graph. However, you've pretty much already been working with this graph. If you look at the bottom of page 103, look at the bottom of page 103. Do you see that circular graph? Pi 6, pi 4th, pi 3rds. Do y'all see that?
Yes, ma'am.
Okay. What does that look like?
A unit circle.
It does, except that a unit circle only goes out 1 unit. A polar graph can go out as far as you want it to. Notice how you have 2, 4, 6, 8, 10 on the x-axis. Does that make sense? A unit circle is very, very specific polar. It's only 1 unit out. Does that make sense? But now we're going to be able to go out as far as you want to. So the polar coordinate system has a fixed point in the plane called a pole. So when you think of the pole, it's the same thing as the origin. So just think of that point in the middle. But we call it a pole if we're in polar form. And the ray, called the polar axis, is where you start. So I want you to think of this as the positive x-axis, because that's what we've been calling it. So we're just learning vocab for right now. If you're in polar form, if I say, hey, the origin, on your homework, it might call it the pole. And I'm like, oh, we start at the positive x-axis. That's the polar axis. Is that cool? So you still travel everything. You already know all this. If you still travel this way to get a positive angle. Okay. And so we know how to do that. All of your points that they give you are going to be r comma theta, where r, of course, tells you the radius of your circle, because we're no longer doing just the unit circle. Your radius can be however long I want to make it. And then, of course, theta is the angle that you travel. Yes. Is that okay? Now, one thing that we didn't have to worry about, because we'd never had a negative radius, is if you have a negative radius, what it does. So if you have a negative radius, it makes you travel 180 degrees. It makes you travel 180 degrees. I don't know how else to say that. So let me give you an example. Let's say that I had -3 comma pi fourths, and I wanted to draw that -3 comma pi fourths. Do you agree that pi fourths would be here? That'd be pi fourths, right? But since it's a negative radius, it flips 180 degrees. So this is where your point would be. Okay, so in polar form, if you have a negative radius, you go ahead and travel to where you need to travel to. But since it's a negative radius, you're going to actually flip it 180 degrees because it turned it. Okay. No questions? Let's practice and we'll see if we understand. So let's just practice plotting. Let's say that we had 4 comma pi thirds. I don't have your gorgeous picture in front of you, okay? So what you would do is you always start on the polar axis. You would go to 4 on the polar axis. And then you're going to travel pi thirds units. And that's where you put your dot. Ugh. Is that okay? Any questions? Okay. The next one is 2 negative pi fourths. So then you're going to come over here to 2. But you're going to travel a negative pi fourths distance, which means you're going to go this way, right? So if you travel a negative pi fourths distance, I'm here, I'm cool with my point being there. What value are you actually at there? What's over here? What angle is this?
7 pi over 4.
Yeah, so that's 7 pi over 4. So that's where you are. Easy peasy. I'm plotting these points. The next one is negative 3 pi 6. Negative 3 pi 6. So I'm going to go to 3. Here's 3. I'm going to go to pi 6. Here's pi 6. But then once you get there, what do you have to do?
Travel 180.
You do. You have to travel 180 degrees. So if you travel 180 degrees, where do you end up? Ooh. What is this angle? Nope. You're at pi 6 and you're traveling 180 degrees. So you should be in quadrant 3. Yeah, 7 pi over 6. And so that's where you would be located. That would be your dot. How are we feeling? Fun, right? Okay. Let's say you have negative 5 pi over 3. So I'm going to come over here to 5 because that's where I always start. You always start on the polar axis. So I'm going to have 5. And then I'm going to go to 5 pi over 3. So where's 5 pi over 3 located? Right? All the way over here. Kind of the way mine's is. Here's 5 pi over 3. Okay. So there's 5 pi over 3. So I was at, where was I? At 5. And I'm over here at 5 pi over 3. But then what do you have to do?
Go 180 again.
Go 180 again. Does that make sense? And if you go 180, wouldn't you end up at 2 pi over 3?
Yeah, I texted Dara after the last meeting.
Okay. And then E says 0, 5. And then you just plot that one like normal. 0, 5. You're actually on the axis. So here's 0 and 5 units. Nope, I'm lying. I'm lying. Sorry. Wrong. Sorry. Where's my... Ooh. Yes. Ooh. Sorry, I plotted this one wrong. No, I didn't. I'm lying. I'm sorry. It's 0, 5. I didn't. I was just thinking about something. So 0 tells you your radius. So that means you don't go out. Your radius is 0, but you're still going to travel your angle. So that'd be 0, 5. Pretty sure that's what it is. So I think that's where that would be, is 0, 5. How are we plotting the points? Are we okay? Because I'm about to make it a little bit harder. Okay. Let's go to example 2. Yes, that's at pi halves. Okay. So let's go to example 2. Example 2 says, I want you to give me 2 other polar coordinates that represent this point, one where r is greater than 0 and one where r is less than 0. I'll help you with the first one. So A gives you 1 comma pi over 3. So the first thing that I would do is I would sketch this. So I would go 1 unit, I'm cool with that. And then here's pi thirds. So here's pi thirds. So my dot would be right here. Is everybody okay that this would be 1 pi thirds? Remember, the first one's your radius, and then the second one is your angle. So you have 1 pi thirds. Is that okay? So now what I'm going to do, I want to find 2 more points, 2 more polar coordinates that would land in the same spot. I have to land in the same spot as this one. It wants one of my radii to be positive and one of my radii to be negative. So then do you agree that I can come over here? Let's start with the positive one first. Here's 1. Okay. If I wanted to come back here, couldn't I just go 2 pi distance around?
Yeah.
Right? So that would be what, 7 pi over 3? So I would have 1 and then go all the way around, 7 pi over 3. Wouldn't I end up in the exact same spot? Or couldn't I have done 1? There's multiple answers, guys, and I would accept all of these. Unless they give you more restrictions. All I told you is that one of the R's had to be positive, one of the R's had to be negative. Couldn't I have gone the other way? This went up pi thirds this way, up, but couldn't I have gone around this way? And that would have given me what? Negative 5 pi over 3? I would have accepted both of those. Both of those have a positive radius of 1, and I end up in the same spot. Do we agree with that? Any questions? Okay, this is the one I actually did, but I just thought about it. You could have done this one too. Now, the next one has to start with a negative radius. So think about that. Do you agree that if you have a negative radius, wherever you land, you're going to flip 180 degrees? Do you agree with that? So I really want to land here at this angle. I want to land at that angle. So I'm thinking about it. What angle is that? 4 pi over 3?
4 pi over 3.
Yeah, it's 4 pi over 3. So then wouldn't that be 4 pi over 3? But because your radius is negative, wouldn't it flip 180 degrees, landing you back here, which is exactly where you want it to land? So both of these points are different technically than this one, but you would land in the same exact spot. Does that make sense? One comma negative 5 pi over thirds, you would still end up here at 1 pi over thirds. You just went this way. You started here, you went this way. Yeah? Is that okay? So this could have been an answer. That's not the answer I did, but if you came up with this one, then that's absolutely fine. Okay, so all three of these are right. You just need one. Okay, so keeping this in mind, you try B and C. Come up with 2 points that would end up in that same position. I'll do it. Ooh. What did I just do? I'll do it. He wants to play. No, I'm not going out there. It's too cold. Don't make me mad. Are y'all done? Sorry, I need my dog in. Testing, testing. Can y'all hear me? Hello? Okay, sorry. My dog was in the backyard and he's crying, but he didn't want to come in. Okay, here we go. Are we done? Anybody get anything for B? Okay, so did you start with sketching this one? What quadrant is this in? Okay, so you went to pi over 6, but then you had to switch it, so you're here. So do you read this one is here? Are you in this? Okay, so that's this picture. Okay, so now to give me a point that you think will end you in the same place. No, yeah, that's why it's here. That's why that's here, because pi 6 is over here. You flipped it. This point and this point, that is that point. They're the same. So what you're trying to do is you're trying to come up with 2 more points that will land you in this same position. Does that make sense? It is flipped. You did flip it. Didn't you? It's in the 3rd quadrant. Where's pi 6? What quadrant? And then what did you do? You flipped it. I know. I agree with you. You're saying I thought you said like you did that. I agree with you. That's why you're in the 3rd quadrant now. So what point now will end you here? The same place.
5 pi over 6. Is that right?
No.
It's
5 pi over 6.
It's 4 7 pi over 6.
Yes, that's one.
And then you could do,
Yeah, well,
what did I do? -4, comma,
yeah.
negative 11 pi over 6.
Very good. I agree with both of these answers. I agree with both of those. So let me try to do it in a different color. This one's orange. So here's 4. If you travel 7 pi over 6, wouldn't you end up here? Ended up in the same place. Cool. Erasing those. I'm going to do this one. Okay, still start at 4. If you go negative 11 pi over 6, I'm going to travel negative 11 pi over 6. Wouldn't you end up here? But because it's a negative radius, I have to flip it 180 degrees. So you would end up here, same place. Both of those answers are correct. Okay, let's try C. First, you have to draw the picture for the problem given. So if we're going to draw this picture, negative pi fourths, do you agree that negative pi fourths would be here? Here's negative pi fourths. Does everybody agree with that? But then what do you have to do? You have to flip it because you have a negative radius. So here is your picture. Maybe we shouldn't say flip. Maybe we should say that you have, yeah. Okay, yes. No. Okay, hold on. Maybe this will help. This is the radius. This is an angle. Because this is negative, I am going to add 180 degrees or pi to the angle. I'm going to flip where it is. So this right here is negative pi fourths. That's normally where it would be. But because I have a negative radius, I have to travel 180 degrees or pi. I have to travel pi. So you have to flip where you are. So this is where my actual point is. 3, I would have stayed there. Yes, I would have stayed there. So this tells you where you go. Your angle always tells you where you go. But then if your radius is negative, you're not done. You have to travel another 180 degrees. Does that make sense? Okay, so now we're here. I'm erasing where we're not. We're here. So now what I'm asking you to do is I'm asking you to find me 2 more points. One with a positive radius, one with a negative radius that would land you in the same location as this point. Does anybody have any ideas?
Three and 3 pi fourths.
Yeah, that's one.
For some reason,
Negative 3 and 7 pi fourths.
Negative 3 and 7 pi fourths. That's 2. I would accept both of these answers. Dre's and Marcus, get up and go to the room. Stop playing with the dog right now. Is everybody okay? Moving on. Ooh, insert. Hold on, sorry. What did C look like? This is the original picture. That's this point, the point that was given. That's that picture. And both of these points will give you the same picture. Does that make sense? You never start there. Where do you always start? Let's go back to the video. Where do you always start? Okay. All right. So the next thing that we're going to try is now you want to be able to go from formula to formula. You are used to the rectangular plane. You're used to the rectangular plane. That's what we have x comma y. You have the x-axis, the y-axis, the origin. That's what you're used to. We are trying to learn a new system, the polar plane, which is r comma theta. It's really circular, right? You have the polar axis. You have the pole, which is the origin. And this is theta equals pi halves. The y-axis, they call that theta. It's pi halves, basically, what it is. And so these are the two axes next to each other. So if you look at the very important note, I wish I made this bigger, to change from polar to rectangular. From polar to rectangular. You want to keep this in mind, that x equals r cosine of theta, which you already know. Doesn't cosine of theta equal the x value over your radius? Except when we were dealing with the unit circle, the radius was 1. So x was your cosine and y was your sine. But now your radius doesn't have to be 1. So that's why you have to make note that it's x over r. Okay, and then the other way, if you're going rectangular to polar, which is the next note, you don't have to write any of this down. You should already have it. It's right there. You're just looking at it. You know that x squared plus y squared has to equal r squared. Pythagorean theorem, right? Your x value plus your y value has to equal your radius value. And then the next one is the tangent of theta has to equal y over x. This I want you to write down. Huge note. You have to think about what quadrant you are in when finding the angle. I want you to star that. I want you to highlight it, box this bad boy, because you are going to be using your calculator and you're going to be like, I swear my calculator's giving me this number, but WebAssign says it's wrong. And I'm literally going to reply, think about what quadrant you're in when you're finding the angle. And that's all I'm going to say. That's it. You're in the wrong quadrant. So this is literally the most common question I get when doing this. So I have this on copy paste. Think about what quadrant you're in when you're finding the angle. Okay? Because that's going to be the common mistake. All right, so let's practice. Insert. Page. Okay. The first one says, find the rectangular coordinates given polar. So if you look at example 3, we're in polar, we're going to rectangular. They're giving us polar points and they want the rectangular ones. So A says 4 theta, 4 pi, sorry, 4 pi. So this is your R, this is your theta. Okay, we are trying to find X and Y. So you know that X is equal to R cosine theta. So X is equal to 4 cosine of 4 pi. But what is cosine of 4 pi? 1. So X equals 4. So I know my X value is 4. Y is equal to r sine theta. So y is equal to 4 sine of 4 pi. Sine of 4 pi is 0. So y equals 0. So if you have a polar coordinate that is 4 pi, it's the same thing in rectangular of 4, 0. I'm going to give you a second. I'm going to show you something. Any questions where I got anything? Okay, no questions? Okay. So something I wanted to show you is we know how to plot that. You go to 1, 2, 3, 4, 4, 0. Here's your dot. Let's plot this on the polar plane. We just practice plotting. So wouldn't you go a radius of 4? So 1, 2, 3, 4. And then don't you have to travel 4 pi? So here's 2 pi. Here's 4 pi. Wouldn't you end up here? Make sense? It's the same thing. Okay. B says -5 pi over 3. And I want to change it to a rectangular point, x comma y. So go ahead and try this, and then we'll talk. Are we okay? Anybody get anything? What is cosine of pi thirds? Hello? Testing, testing. Oh, thank you. I don't know if y'all can hear me. Okay, so -5 over 2, right? Okay, so let's see if this makes sense. So what if rectangular were cool? What quadrant would this be in? If you were to plot this point, what quadrant would it be in? -5 halves, -5 square root of 3 over 2. You're here. Wouldn't you be in quadrant 3? Do we agree with that? So let's talk about the polar form. So here's 5. My radius is 5. Pi thirds. Isn't pi thirds here? But what has to happen? You would travel 180 degrees. So you end up in the same place. Any questions? You try the last one. Try C, and I guess that's where we'll stop today. Absolutely. All right, we ready for this one? So this is polar. We're going to rectangular. So we have x equals 2 cosine of negative pi over 4. And you should have y equals 2 sine of negative pi over 4. You have the hiccups. So this gives you what? 2
square root of 2 over 2.
Square root of 2 over 2. Thank you. Which equals just the square root of 2. And this one gives you 2 times negative square root of 2 over 2. No. So then you get the point. The square root of 2, comma, negative square root of 2. And that is your rectangular point. And then if you wanted to sketch the picture, this one ends up in the what, fourth quadrant? You're here, right? And this one, you're going to travel negative pi over 4. So I'm going to travel negative pi over 4. And you're going to stay there, right? So you end up in the same place. And that's it. So that's how you switch from polar to rectangular. I have a question. Possible real world applications. Yes, they do, Jude. Sonar, radar things, you know, like in the submarines when they're trying to find whales and stuff based off of sound, right? They're doing this based of stuff around them. They switch to a polar graph rather than a rectangular one. And they talk mostly in degrees, not radians. We're just being consistent. Everybody okay with this? Pretty cool on the polar going to rectangular? It's the other one, the other way that's like, ugh. So we'll practice with that tomorrow. All right, we'll stop here for today.
I do
Y'all
have
have
a question.
Oh, sure, go ahead.
How do we see what we missed on the exam?
I don't think I can show it to you until everybody's taken it.
Oh, okay.
Any other questions or concerns? All right. Well, I'll see you tomorrow.